Next I want to support different integer radixes in Plum. So let's actually open up a Plum file. Currently you can only write numbers like this, and that's it. I want to add support for binary numbers, hexadecimal numbers, and actually any base that you want. So the way I want to do that is by, if you just write a number, that's a decimal number. But optionally you can put a radix in front of that, and then a colon maybe. So this would be a binary 1, like this. You can write stuff like this. Or you can say I want a hexadecimal number, and then, I don't know, something. Yeah, that's the basic idea. So let's generate an array that contains this number, I guess, in hexadecimal. Sure. Some int. Let's also, let's just try to run that and see what happens. It's gonna fail, of course, but it's gonna be interesting to see how that fails. So plum make run playground. Alright, yeah, expected the closing parentheses, that makes sense. So at some point we are passing integers in here with this nice to do, allow the radixes. Nice. So basically that's what we want to do today. We consume white space, and this is the number that we basically evaluate to, the number that gets returned. Alright, we store the position of the cursor, makes sense. And then we pass the current character. If that is a digit, we continue, otherwise we break. Alright, and if we continue, then we store the number times 10, I see, plus something to an int, and we advance. Alright, so let's maybe have an extra parse int literal, I don't know, parse int that accepts parser and a known radix. Yeah, stuff like that. And basically I want to factor out this part, I think. Pass int alpha. This is intended to only be used internally by this parse int function. Yeah, basically in this part we need some way of, oh, you know what, let's actually have like digits. Can I have a radix more than 16? Maybe. Maybe not. I'll leave it like this for now. Digits, and then what we can do is, rather than checking is this a digit, because for hexadecimal numbers we also want to allow these letters, so we just do digits dot like substring from 0 to radix. That should contain the character, otherwise we break. Yeah. And then that's that. And this right here is basically the index of the character in here. So is there, I don't know, an index of find, something like that. Let's maybe open up the Martinez standard library iterators. iter. No. Okay, there is contains, that's nice. Take and enumerate and zip get find. Haha. Yeah, that's pretty cool. Dot find, and that returns the position of that. Pretty nice. So we can just do digits dot substring to the radix dot iter dot find the character, and if that doesn't exist, then we break. That is quite nice. Is it like substill or slice or something? And then if this would be just that. Nice. Let's just make a mutable iterator. Quite cool. Alright, so then we need to return the parsed number. Fair enough. That will be the number at the position start to end. Alright. And then in here, we want to allow these other radixes. So first we consume white space, then we parse a number, parse an helper with radix 10. And then we basically want to check if there's a colon afterwards. Then we parse another number. So we do parser. Yeah, we basically call this helper function again, parsing a number again, but this time using the kind of previous number as the radix. And that number that we parsed there, that's going to be the actual number. So this is the radix then, and then this is the actual number, and then let's say number is oh, I see, this returns a maybe, and if that returns nothing, that's totally fine. Then we just do this, not an int in here. Alright, so this is an int and source. Yeah, and then in here we say this is your actual.int at, and then the source is going to be the radix dot source up to the actual source. Like all of that belongs to this number. And then we just return that. Clean, I think. Yeah. Let's see if that works. Not quite. Not very long. Oh, so actual is maybe again, sure. But after the, if you write a number and then colon, after that there has to be a number. If there's not one, then that's a bad input. We probably need construct an error here with a source, so that would be parser dot rest, source of rest or something. Something like that. True. So here we can return a result. And then this is going to be no match. I like it. It's int and source, but it's something else. True. That doesn't make any sense. All right. In the end, we passed a number. True. This can be an error, in which case we return that immediately. That seems like it does something. And it works. Nice. Actually, there's one more thing. I think I want to support underscores in here. Maybe not for, you know, like it doesn't really make sense in hexadecimal numbers, maybe. But I know that this can be very useful in binary numbers, you know, grouping this into like groups of 4, groups of 8 or something. And in, well, in normal numbers, also useful for, you know, steps of thousands and millions and so on. So I think this should be possible as well, which means that in the int parsing, in here we basically want to check if the char is an underscore. That should be allowed. Then we just want to advance, you know, consume that basically, and continue. Hang on, we can do, you know, if consume boom, we can do that. That's a bit simpler. What's going on there? If there's not a variant, true. If that is sum, then we continue. That's a confusing error message, but yeah. It's because ifs are directly desugared into switches. So the if kind of implicitly has a switch with a true variant, I think. Yeah, but this works. Alright, so let's commit that, and that's it for this video, actually. Hang on. Yeah, I don't care about that too much. Support other number radixes. And underscores. Beautiful. Committing that, and that's it for this video. So, see you in the next one.